today, grade 12s, I'm going to go through a very nice long question based on your work, energy, power, and it's also got forces in it. So this is actually a very nice question. I would suggest that you make sure you can do this type of question. And when I say do it, I don't mean that you just follow me. I mean that you actually can look at the question, stop the video, try and do the question by yourself. Once you've finished it, go back and see if you've got it right, because that is the way that you learn. Right, it says a healthcare worker, while pushing a patient on a wheelchair, approaches an incline, length 10 meters and height 1.5 meters as shown in the diagram. The combined mass of the patient and the wheelchair is 120 kilograms. This says there's a constant frictional force acting on the wheelchair, so frictional force is always upwards, of 50 newtons. As it moves down the incline, the rotational effects of the wheels can be ignored. Now it says the worker exerts a force on the wheelchair which is parallel to the plane, so the wheelchair moves down the incline at a constant speed of 1,25 meters per second. Okay. Now it says, is the mechanical energy of the wheelchair conserved while it moves down the incline? Give a reason for your answer. And the answer is no. And why? Because of friction. As soon as you have friction, and in fact, not even that, we don't have friction, and we have the worker that is basically slowing this down. So the mechanical energy is not conserved at all because of the friction and the worker. We both are forces that are acting in the opposite direction to the motion of the wheelchair person. Now it says, what is meant by conservative force? This is theory, and it's important that you guys know about conservative and non-conservative forces. But basically, conservative force is one which doesn't, okay, you can think of it as one that doesn't matter what path you take. So it doesn't matter if we went along this length or we went along this. So a conservative force, another way of thinking of it, is it's basically your non-contact forces. Your non-contact forces. But a conservative force is one where it doesn't matter what the path is that you take. Okay. Oh, so it would be your non-contact forces. So what is that? That's gravitational force, electrostatic forces, and your magnetic forces. Okay, those are your conservative forces. Right, let's carry on with this question. So I've copied this over here so that we can see the information. Now it says, draw a labeled free body diagram showing the forces that act on the wheelchair as it moves down the incline. Indicate the following forces on your diagram. Isn't that nice? Normal force, frictional, component of weight that acts parallel to the incline, component of the weight that acts perpendicular, label is force D, the force exerted by the healthcare worker on the, okay. So that's pretty nice. They've actually told us all the forces that we have to do. So first of all, free body diagram is a dot, okay, colored in circle. And because it's on a slope, I like to do a little dotted line here to help me see where the slope is, just so that I can keep my parallel lines and things in the right place. Okay, so now it says we want the normal force. So normal force is always 90 degrees to the surface, and we're going to label that A. And remember what I always say, tick off what they're asking us to do so that we can make sure that we get it right. Now we need to label the frictional force. Now the frictional force is always in the opposite direction to movement, and it's always parallel to the slope. So this is moving down the slope, so therefore the frictional force is going to be here, and that is B. Done. Then it says component of the weight that acts parallel to the incline. Okay, so do you agree that the weight is, okay, I'm just going to change color quickly. The weight is pulling the object straight down. That is the force due to gravity, right? So the force pulling it down, the force of gravity is pulling it down, and it's doing two things. The one thing is it's pulling it down the slope, okay, and that is the force of gravity, and it's parallel, and they've asked us to label the C, so that is now C. And the component is the weight that acts perpendicular to the incline, so that's going to be this force here, and that's going to be D. And what you need to realize is that A and D are perpendicularly opposite to each other, and they are equal in length, okay? So that's D. They also want the force exerted by the healthcare worker on the wheelchair parallel to the incline. So the worker is also pulling it in the opposite direction to its motion, and we're going to label that E. And what you need to realize is that C actually has to be equal to the sum of E and B. So it has to be much longer. And how do we know that? Because this is traveling at a constant speed. It's traveling at a constant speed. Okay, tells you 1.25. Right, so therefore the net force, F net, equals 0. Okay, now, another thing I need to tell you is my drawing is a bit rough because obviously I don't have a ruler, I don't have an eraser, and I don't have a pencil. You guys, I do not want to see this type of thing. I want it beautifully neat with a pencil, using a ruler, straight lines, etc., etc. And these should be drawn equal in length, but if you can't manage it, then feel free to put these little lines like you do in geometry to show that they're equal. And then please make sure that your circle is big enough that it incorporates all the forces. Okay. Right, now it says calculate the magnitude of force C. So we want force C. So do you agree that since the net force is 0, F net is the sum of all the forces, and F net is going to be C plus E plus B. Okay? It's the sum of all the forces. I know that those are in opposite direction. I'll worry about that in a minute. But the net force is always the sum of all the forces. I'm going to choose the direction downwards as positive. Therefore, the F net is going to be C plus minus E plus minus B. Now, you guys don't need to do all of this. I'm just showing you what my thinking is, okay? So we know the force of friction is B, and they've told us that is 15 newtons, okay? So B is easy, that's minus 50 newtons. E we have to calculate because E is equal to this horizontal component here. And we're going to be looking at that there. Now, normally we get given this angle, which is the angle of the slope. But this time we weren't given the angle, we were given the length of the slope and its height. So do you agree that therefore we can use Pythagoras, or actually we can use trig, where this is 1, 5 and this is 10, to find out this angle? But by doing that, do you agree that we're going to be using sine? So if I call this theta, do you agree I'd be going sine of theta is equal to 1, 5 over 10. Okay, happy with that? And then we could find theta. But let's look at how we would find this line here, which is E. Let's say that this angle there is theta. Okay, then this would be the opposite side, and this would be the hypotenuse. So do you agree to find this side, I would be going sine theta is equal to the opposite over the hypotenuse, right? Agreed. And do you agree the hypotenuse is the weight? So I'd be going sine theta is the opposite over FG. So therefore I can say that I can get E, I don't know where to write this, so it's here. E is the opposite side, is going to be FG sine theta. But Fg is the mass of this thing, which we know is 120 kgs, times by 9,8. And sine theta, we've just proven, is 1, 5 over 10, which is actually going to be 0,15. If you just divide 1, 5 by 10, you get 0,15. So therefore we can work out E by getting out our calculators, and we can say 120 times 9.8 times 0.15 equals 176.4. So this equals 176,4 newtons. Okay, so now we've got that F net, which is 0, because we've said that since it's going at a constant velocity, it's got no acceleration, so therefore its net force is 0, is equal to C minus 176,4 newtons, that's E, minus 50 newtons, okay? So therefore, do you agree that C is equal to the sum of this, which is going to be minus, that stays a 4, that stays a 6, and 7 and 5 is 12, 226 0.4 newtons. So C is going to be equal to 226.4 newtons. 226.4 newtons. Okay, and then we might as well just write this down. B is 50 newtons, and we worked out that E was 176.4 newtons, just in case we need it. Now it says write down without doing any calculation the amount of work done on the wheelchair by force D. Give a reason for your answer. So we're looking at this force here, which is the force of gravity perpendicular to the surface, and the answer is 0 work done. And why? Because the force is perpendicular to the direction of movement. In order for work to be done, the force has to be parallel or in the same plane as the direction of movement. Now we've got state in words the work-energy theorem. Now remember grade 12 is what I keep saying, learn your theorems, learn your definitions. The work-energy theorem states that basically the change in kinetic energy is equal to the change in the net work done on an object. Okay, that's all it is. And why are they asking us that? Because they're hinting that we're going to need this to answer some questions as we go down. Now it says calculate the work done on the wheelchair as it moves down the incline by the force labeled B. So they only want the work done by the force labeled B. So work done is equal to F delta X, and B happens to be parallel to the surface, so it's going to be your 50 times by the 10 meters, which is 500 joules. Easy peasy, right? Then they want the work done just by C. So that's going to be 226.4 times 10, which is going to be 2,264 joules. Okay. Now it says use the work-energy theorem to calculate the work done on the wheelchair by the force labeled E. And E is your force of friction. Now there are two ways to do it. We can either say, okay, fine, well it's pretty obvious that we have the force E, we've worked it out, it's 176.4, and then we can subtract the 2 and times by 10, or we can realize that the work done by B minus from the work done from C is going to give the work done by E. Because why? Because that here is telling us, the work-energy theorem says the change in kinetic energy is equal to the work done, the net work done. So the net work done, W net, is going to be the net work done by B is going to be 2264 minus 500, which is going to be 1764 joules. Okay? Easy enough. Then it says determine the average power output of the healthcare worker as he takes the wheelchair down the incline. Now if you look at your formula sheets, you can see that power is equal to force times velocity. We have the force applied by the healthcare worker. The force is E, which is basically going to be 1764 newtons. The velocity of the healthcare worker is 1,25. So then we can multiply those. Let's use the calculator. So it's going to be 176.4 times 1,25, and that is 220,5, and what's special is that it is measured in watts. And that grade 12 is how you do this very, very nice long question. Please make sure you can apply your work-energy theorem and use your power equations to work out this type of equation, because this type of question comes up often. Have a great day.